everyone, welcome back to Dragonfly Engineering. So this week we're going to continue on the dual shot mold. This is the double mold set that's going to rotate in this rotating platen on the big molding machine here. And this week we are going to we did assemble both of the B sides, including all the ejector pins, and now we're going to burn in the B side cavities into the ejector pins and the mold insert blanks. And I tried out a way to basically machine all 5 of the electrode profiles so that we can burn all 5 cavities at once, because there's 2 rows of 5 on both mold sets, so a total of 40 cavities. So, hope you enjoy. Thanks for watching.
So earlier in the week, I did a lot of the milling of the mold bases to get all the holes for the ejector pins in place. So here you can see how we're center drilling all the locations for the several dozen ejector pins that we're going to do. And then we follow through with a lot of CNC drilling of the holes, which will then lead to the final steps of machining some toe clamps into the corners, or some pockets for some toe supports to support the steel frame when we inject plastic in. And then there's threaded holes that will hold these toe clamps in place for the mold itself. We'll talk more about that later. And then after all of this milling was done and drilling and reaming, then we are ready to assemble the bits and pieces, all of the ejector pins and the back ejector plate.
This is going to be the first of the 2 identical B sides. Let me get this out of the way. And I've been machining the graphite electrode in the Herco mill over there, which I can show you in a second. And that first pass roughing graphite electrode is ready to go. And from our experiences burning the first half, or the A side of this mold, we wound up going ahead and making an electrode that would burn all 5 cavities at once, as opposed to our first round where we machined 1 cavity per 1 insert here in the mold at a time and then refreshed. It took a little bit of time, and I realized that I believe the EDM machine is going to burn all 5 of these cavities faster than doing 1 individually at a time. I know the time for the EDM process, which is electrospark machining of the cavities, it does take longer as the surface area of that you're refining down to a fine finish, it gets bigger. And the time to EDM burn a finished cut into a mold also increases as the surface finish, or the fineness, or the surface finish spec in microns gets tighter and tighter, or flatter and more sharp and refined. So, but what I'm going to do here is see how we do with doing a refined cut on all 5 cavities at once with a larger electrode. And we can basically compare to see which is faster, roughly, doing 1 cavity at a time and refreshing that insert as the mill is going, and refreshing 1 insert, and the EDM machine is cutting with the current insert, and then we flip, or going ahead and machining all the graphite inserts as a single block and then running them all parallel. I think also for the B side, which is the polypropylene substrate of this part, we don't need to have as good of a finish that we got with the finishing electrode that was machined with copper. And I can show you an example of that here pretty soon. So this is the result of the first round of rough graphite EDM burning of these cavities into our steel inserts, followed by the copper finish of EDMing with these 2 duplicate copper electrodes. You can still see the soot that is on there from the finished burning that we did. So in this case, I roughed out these cavities with the graphite, which is actually that guy right there. You can see that it's losing some of its fidelity. And then we finished with the copper, which has retains its fidelity of the shape a lot better, where it resists the electric spark more. So that's what we did. We roughed with the graphite and finished with the copper, and I was
cutting one copper electrode or refreshing in the mill while the other copper electrode was on the EDM machine, and we just keep swapping. So that's what the first round looks like.
I don't know if I got much footage of the copper burning, but it's very similar to the graphite, at least visually. Yeah. So that is the plan. The other thing that we are going to do here to save ourselves a lot of time is we are going to build up this mold base, the B side, with the ejector plate and the riser blocks and the base and everything, and the ejector plate clamp, which is this structure right here, which we can zoom in on in a second, to house all of our ejector pins, which we've got a whole slew of 3 different sizes of ejector pins, which came from, I purchased these on McMaster Car. But ejector pins can be a huge hassle if you've got a mold where you have to cut each ejector pin with like a carbide blade or something, and then put each individual pin into the surface grinder, and then grind each one to height. In this case, since there's so many ejector pins and 2 mold bases, my attempt is going to be to load all these blank ejector pins without having to cut anything. And we've stood off the position of the ejector pins with spacers on the bottom plate of the ejector, which are these stripes of aluminum right here, so that we can put these pins in without altering them at all into the mold base, such that the pins will be effectively flush with the surface. So like for instance, this pin will just be almost the same height as the steel block that we're going to burn our cavity into. That way we're going to burn the top of the pin off, and it will be perfectly matched to the cavity because it's all steel that the electrode is cutting. And then we'll be done. We won't have to do individual work to individual pins, hopefully. I am a little concerned that sometimes with EDM milling, you get some spatter, some overflow, or some overlap of the microscopic kind of molten and then re-solidified steel surface from the spark erosion. You know, it's a bunch of little blown out, partially molten and re-solidified craters and spatters of metal. So there probably will be some deburring that has to happen. But I'm hoping, because of the fine finish that we're setting the EDM to cut, that will be a minimum amount of work to do. But it'll still be way less than grinding each pin individually. So I'll zoom you in, and I will start the process of building up our mold base first B side. And then we can go and I'll show you how we assemble our inserts into the second mold base. So we may be going a little bit out of order, but I want to get this first mold base burning in the EDM machine with the graphite electrode, and then we can go and backfill and start building up this second mold base, which will basically have the exact same EDM process done to it. So let's zoom in. So looking at our B-side plate with our inserts, on a previous episode I showed how I roughed out the pockets that hold these individual steel inserts, which this is one individual steel insert. This is going to go in the B-side, or the second B-side, or the duplicate B-side mold half. Anyway, these go in right just like this. So I showed how these were machined in a previous episode, and I also showed how we EDM roughed out these squares. And then after the EDM roughing of these 1/2-inch steel A2 plates, you can probably see the aluminum base that was purchased, and then the steel plates are basically bolted and pinned on with dowel pins. And then we inserted these machined or these squared up and then pre-machined and pre-ejector pin hole drilled and reamed holes here, and loaded all those into the mold base and screwed them down in the corners with some M3 socket cap head screws. Now what we're going to do is I'm going to build up this B side with these mold inserts and plate and populate all of our ejector pins. So this pin will go through a through hole in the back of the mold base, which has a little bit of clearance, you know, so that we don't need a reamed hole going all the way through the block, but we do want a precision reamed hole at the top of the block. So yeah, back here the ejector pin is a little on the loose side so that we can assemble it all. And then as we approach the front, then we are getting into a precision reamed hole, which is about 1/2 thousandths larger, or about 12 microns larger in diameter than diameter of the ejector pin itself. You don't want this fit to be too tight because you can start having situations where the steel will gall up on itself. You know, the steel of the pin will start to rub and create a little ball of powder of steel in the cylinder. And then that little ball will start rolling and get worse and start flecking off more and more steel until you have like a little BB of steel that is pushing and rolling and getting worse and worse and eating away and then ultimately jamming your pin up. So that's basically the galling effect that happens. So I usually do about 5/10 thousandths clearance, and you can spec your reamer to size. But typically these pins, at least the ones I buy from McMaster-Carr, are about 25 microns or 1/1000 smaller in diameter than what they label on the side here. Okay, so that is our setup for the main block. So what we will now do is get our ejector plate clamping top, which is this structure. And you can see that we've machined some pockets here. There's a 2-level pocket. Let's see if you can see this. Yeah, so because we've got 2 types of ejector pin bottoms or retention knobs or whatever you want to call it. And we want these knobs to basically be flush with the top of our ejector plate. And I'll show you why in a second. But, you know, so we've got an 1/8 inch ejector pin base, and then we also have a 3/16 ejector pin base. This foot retains the pin and the ejector plate assembly, which is 2 plates. The top plate, which is the clamp plate, and then the bottom plate, which is more precision machined and is the actual height setter for the ejector pins. So let me show you how this works. So we will put the ejector pin with a 3/16 base on it into our clamp plate, and then this clamp plate will bolt onto the bottom plate so that there's no gap between the plates, and our pin is retained here and relatively snugly. I usually like to keep a little bit of play because we need, I don't know, like 40 pins to line up in these holes. So giving yourself a little bit of wobble space is good on the X and Y axis. You want a little more retention on the Z axis so that your pin isn't drifting around when you're molding parts. So this looks good. So that's why we have this interesting 2-step pocket profile. Some people actually just machine a big groove through here, but we wanted to maintain a little bit of strength, so there's actually kind of pockets to create a rib structure just to help with the strength of this clamping plate. So, looking at the back of the mold, we've got also holes for our guide pins, these guys right here, which go into its own pocket to hold the foot of the guide pin, or this is also could be considered a huge ejector pin too, but in this case it's a guide pin. So we can drop our pin into our pre-machined pocket here, like so. And I will put them all in. These pins are also called return pins, and they serve 2 functions. One is to basically keep the ejector plate guided correctly in the bearing holes in the back of the mold. And the other purpose of these guide pins, or return pins, is to ensure that the ejector plate gets pushed back when the mold closes. And I can show you how that happens here in a second. Let's get these. And usually when you buy a mold base, one of the guide pin holes is offset by 1/8 of an inch or 3.2 millimeters relative to the rest, so that you don't get your orientation backwards. And I may have already messed that up. So let's see here. Okay, so one of these holes, usually where the origin is different than the rest. Okay, so here is our stamped in origin right there. So here's the American Quality Molds, or AQ molds, which you can go online and buy your own. They're in Indiana in the United States. Pretty good molds, yeah, or mold bases. Good prices too. They're not sponsored, but that's who I buy from. And so where the origin is, this hole is probably the one that's offset by 1/8 of an inch. And I can see that it's 1/8 of an inch deeper than the one over here. So what we will do is find the hole that is 1/8 inch lower, which looks like it's this one. Is that right? Oh yeah, but I'm looking at the back of the mold. Yeah, so our origin from the back side of the mold matches this offset hole here. So let's see if we can slide these in now. Sometimes a little WD-40 helps. Okay. So yeah, so the first step in putting ejector pins in is to put the ejector plate clamp plates in first. And then if everything I said was correct, then this pin should line up with both offset holes, the one in the ejector plate cover or clamp plate and the mold block itself. And that does go in. So there we go. Okay, so now what we need to do is stick all of our ejector pins into all of the pre-drilled holes that we have in our mold base here. So this is a 3/16 ejector pin. We've got three sizes. We've got 3/16 or 4.76 millimeters. We have a 1/16 or 1.59 millimeters, and these actually have a step on the bottom to help with their buckle prevention, you know, because if you push too hard on too spindly of a rod, it can buckle. So in the travel area of the ejector plate, they actually beef it up with a shoulder, which is 1/8 of an inch or 3.2 millimeters. And then we've got an 1/8 inch pin here, and these are going to help eject the runner system out of the mold. And now it's just a matter of sticking them all in. Sometimes when you drill your ejector pin holes, you know, they can be deep holes because you're drilling through this entire layer of aluminum, and they can lead off. So a lot of times, again, you want to have a clearance hole that's bigger than your actual pin halfway into the block, and then as you get closer to the business end of your mold, you want to start bringing that diameter to the reference diameter and reamed diameter of your pin itself. So I'll put all these in and probably time lapse it. All right, it does look like I overlooked one thing here, which is the sprue ejector pin, which is this pin right here. And what this guy does is creates a plastic well on the A side. So you can probably see right here where the plastic is injecting in from the A side of the mold. But you want a ejector pin here, which is too long, of course, right now. Or maybe it isn't too long. Anyway, you want a pin in the middle here that creates a well, a plastic well, because the leading edge of the plastic that's squirting into your mold may have a skin on it that is partially cured or solidified, and it probably also has some oxides and other nastiness. So it's not very good plastic that's starting into your mold from subsequent shots. So what you do is you create a little well here, so when the plastic is shooting in, the first place it's going to go is into this little well. And then when this well fills up, then fresh, good, clean plastic will flow into the cavities of your mold. So the position of this guy isn't totally critical, but we do want it to be subterranean to create that well. And then the other thing that this plastic well does is it creates a handle to hold on to the sprue on the A side of the mold so that it will pull out of the long tapered sprue or sprue bushing that you have. So here's an example. Here's a green plastic sprue with a little plastic well and the retention handle or knob or whatever you want to call it. this guy has very subtle undercuts in it so that the mold will hold on to the sprue when the mold opens, or the B side of the mold will hold on to the sprue and break the connection that the tapered part that is going through the A side of your mold. It will break the stiction and also pull it away from the nozzle of the molding machine as well. And then when the mold opens, you've got this guy pulling out with the rest of the parts that are on your B side of the mold. And then finally, the center ejector post with the probable undercuts that we will add here so that this sprue is retained correctly, will then, the center post will then eject it out like that. Or in our case, we are going to eject it out partially like so, and then the robot, the big yellow robot, is going to come along and grab the sprue plus the rest of the parts and pull it off of the mold, obviously when all these pins are retracted. So, but this is how we're looking. I need to add a undercut probably on the clamping side, because this, again, the height of this pin isn't very critical. And since I've already put all of these pins in, I don't want to undo it all, even though eventually we will have to. But it's okay for us to have a hole right here on the ejector plate base, because again, this height isn't needed or very critical. Normally I've got a push-pull rod, a half 13 threaded rod that is exactly centered on the clamping plate. So typically I actually stick a ejector pin through the half 13 rod and into the top plate of the ejector stack, the ejector plate stack, and then I back it up with the actual, threaded rod that pushes and pulls on this mold ejector base. In this case though, since we are going to run this mold in a rotary table, we can't have a push-pull rod because the rotary table will spin 180 degrees and want to break off our rod. So in this mold architecture, we have to bump the ejector plate forward, and it will be returned with springs that we'll get into in a second here. But anyway, this is the first step. And probably off camera, I will drill a little hole in the middle here for our center sprue ejector. In fact, I probably just need to do that now. So I'll be right back. All right, so here's the clearance hole that we added, and then we can stick our back plate onto our ejector plate system, which will clamp all of our ejector pins into place. And as soon as I find the screws, we can screw the back plate back on here to retain our ejector pins. And I did put that center one, yeah. Some of these ejector pins that are not in the cavity itself will probably need to be adjusted in height, so this isn't the final time that we're going to build this bottom portion or the B side of this mold. But we need to kind of build it up to get it into the EDM machine to start machining our cavities with the copper or the graphite electrode. And I need metric. Wait, now these are empirical, so, or imperial. Yeah, I bought this mold base in the United States, so it's all inch based, including the hardware. So due to that, I think all of the fasteners that I add to this thing will also be like quarter inch, 20 threads per inch bolts and such. Oh, another thing that we added to this mold are cooling lines. So there's a drilled hole that goes all the way through this mold block, one on each side. This is a thread for a mold hanger, like a hanging bolt to thread in here to lift the mold and load it into the molding machine. But this is a NPT threaded hole on both ends so that we can put a plumbing fitting there and then run cooling water through this mold as it heats up from molding parts, or more specifically so we can better control its temperature. These parts are kind of small, so I doubt that we're going to overheat this mold, but it's a good practice to have this in case we ever recycle this mold base for some other use in the future that has a higher heat load. All right, so now that we've got our ejector plate in, we can put our riser blocks on, and these basically create a cavity in the bottom of the mold for the ejector plate to travel in and out as it ejects the parts off and then retracts back to the bottom. And it allows for a clamp recess area, which I'll show you in a second here. We do want to make sure these surfaces are clean because we would like to have the top of this mold be coplanar to the bottom, so within 1/1000th of an inch or 25 microns total runout. And that's also important because we're going to use the bottom of the mold to reference the location of the cavities when we EDM burn in the profile. Okay, and then we got our bottom plate here. We've got an airplane flying over, of course. So this bottom plate has 3 holes in it that I machined, and these holes are going to receive the rod from the molding machine that will push the ejector plate forward. So if we assemble here and we pull this side guy out, then a rod will push through here and push on this plate to push all the ejector pins forward. And then we're going to have springs in here that will return the plate back to the home position, which we need to calculate once I finish assembling this mold. So that goes in like so. Then we got these long bolts that tie the whole stack together. Then we got these flathead bolts that will bolt the riser blocks to the bottom plate of the mold. Sometimes these components are dowel pinned to reference their position better, but in this case it's not too critical, mostly because we are just going to clamp on this bottom plate and the whole back of the mold floats relative to the A side. And even since we are spinning this mold, so one A side is going to reference this side of the mold and then the molding machine will spin them around, we still don't necessarily need precision alignment on these back features when they're clamped in because of the procedure that we're going to follow when we load these molds. We're going to load the first mold and then open up that first mold half, spin the B side around to the second location, and then use that B side second location to align the second A side, and then we'll backfill with the second B side on the first A side. So we kind of walk through the process and we just bolt or we clamp the mold pieces down onto the rotating platen such that they're repeatable. All right, we're going to flip this over now, and hopefully this ejector plate will drop to the bottom of the mold. And we can push down on it. Actually, we can hammer on the corners a little. So the actual travel of these pins is only going to be maybe 1/2 inch or 13 millimeters. So if it's a little tight at the top, that's kind of normal because all these pins don't really have any place up here to relieve themselves from getting bound up. So we can hammer on our return pins, which are the safety pins that push all of our ejector pins down into the right position when the mold closes. And we can just get it started. And it should start to free up, or we can just push it down like that. And there we go. Here is all of our ejector pins ready to be EDM cut. And the next step is to load this guy onto the EDM machine, sweep it in so that this surface is flat, and then we will find the location using the EDM tool itself to burn in our profiles, including the tops of our ejector pins. Let me zoom in. There it is. And here's the bottom. You can see some of the pins sticking through. And then our spacer to make these pins fit without having to cut each one of them. All right, so let's indicate this in. We've got this depth indicator on the granite surface, actually cleaned this surface of the granite because it had a little bit of dust on it, and I think it threw off my previous measurements. So here we're at 0 on our indicator and we're on the frame. So I'm going to start dragging this indicator across our inserts, and that one's at 0, that one's at 0, this one's at 0, that one's at 0. This one is minus 1/1000, and I wrote that down previously, so this is confirming that this insert is down by 1/1000 of an inch. So I'm going to have to shim this single insert up by 1/1000 to bring it up to plane with the rest. And then I'm going to add another sheet of 1/1000 shim under all of these, so actually this block will be up by 2/1000. And the reason I'm going to shim all of these up is so that we have what's called a shut-off landing. And what that does is it concentrates the clamp force onto the area of the mold surface where your cavities are. So these little inserts are going to be raised up. So the 100 tons or so is going to be distributed 50 tons on this side, just in this profile, and 50 tons over here. And then this plate will probably pick up some tonnage, but not much. But the idea is to concentrate the clamp force where we need it, which is where the perimeter and or the shutoff landing for the actual mold cavity and molded part is. Oops. Yeah, so I'm still minus 1/1000, and then I'm back to 0 on this plate. So we'll spin the mold around, keeping it kind of almost vacuumed onto the granite surface, which is flat to within probably 2 microns, or 1/10,000th of an inch across the entire surface, so we can kind of drift our measurement around and get accurate numbers. So here we're at 0. That guy's at 0. This one's at 0. That one is plus maybe 3/10, but I think that's okay. It'll squish in. That one's at 0, and this one's at 0. And we'll check the frame over here, and we're at 0 there. So I'm going to drag this guy around, and we're getting a little high in this corner. This is about 1/1000 high, and it could be that there is some particulate, like a piece of dust or something that is stacking up in our tolerance, or it could be that one of these components is 1/1000 or some portion of 1/1000 tall. So, but we are within 1/1000, which is the spec that I like to follow for planarity of the mold surface to the base of the mold. So I think we're good. You know, I did the fuss of tapping this mold in with a rubber mallet off camera, but here we are looking good as far as squareness. Yeah, so let's travel back and forth a little bit, and then that's starting to get into the tool radius of that cut, and we'll speed up and then go back the other way. So yeah, I'm pretty happy with the squareness of the mold here. You know, because with EDM milling, it's the angles or the angular walk-off can be more or just as important as the position itself. set this up.
Oh,
That one's clearly higher. I see a little bit of beginnings of spark. This one doesn't have any. That one's got a lot. I don't know. So this is what the first round of graphite EDM with integrated ejector pins looks like. It's pretty good. This is was a rough and then a finish graphite electrode that was cut here. And you can see just the witness of the ejector pin there. Let me blow this off. So I blew this off. Now we can take a look. Zoom in. There we go. So you can see probably right there the witness mark of a 3/16 ejector. Right there again, close to where the sprue is going to come, or the gate is going to be. And you can't even see the other ejector pins, but there's two in this area. Oh, actually I could see one to the left of that second pin from the top. And then there's two down here, and I can see the witness of both of those ejector pins as well. But it's kind of hard to see them. Anyway, here we go. All right. Well, that'll be a wrap for this week. This was kind of a busy week because I had some plumbing problems at my house, which I'll probably show another episode of, which involves replacing ancient 100-year-old cast iron sewer pipe with modern ABS plastic sewer. So that was a little bit of a time consumption for this week, so apologize for the delay in the next episode. But take a look for the emergency plumbing episode that I'm going to release pretty soon. Thanks for watching.